This meeting is being recorded. And I believe it is better to do the recording into the cloud because the meeting can be big, so it can be, I don't know, 300 megabytes or even more. Just a second. I believe I have started sharing screen.
Yeah.
Do you see my screen? You're supposed to see yourselves.
Yeah.
Oh yeah. Good. Good. Okay. So this is Python notebook. Let me please tell me, what do you see on your screen?
We don't see what you're typing. I mean, if we're supposed to see it, then we don't see it. We see
Line
localhost 8888 notebooks. Untitled 4.
Okay. Oh yeah, I see. So okay.
Yeah, that's right. This screen.
Yeah. So Jupyter notebook. So we will get started with the very famous thing that is called Game of Life. This is a game. So, and definitely you can find out what it is in Wikipedia or on whatever. But this is a simple model of well, of two-dimensional life. So there are. Do we have someone?
Yes, someone else is joining. Is joining.
Hi guys. Hi everyone.
Hi. Can you please introduce yourself? Because you're called SO. Hi.
Hello.
That is a true one. Okay, maybe later.
Okay.
Let's continue.
Okay, maybe later. Maybe later. Okay. Okay, so let's continue. So we will be working with Game of Life. So okay. Someone disappeared. Okay, so Game of Life is the model where you have the rectangle area, and each. So we will start. So to Vladimir and Andrei. So I would rather prefer today to do the introduction of the Game of Life, and probably next time we will be doing with that. How to say, monkey evolution. Does it make sense?
Yes. I agree.
Yeah, I think so. Because if we get started with monkeys today, so it will take several lessons. So someone will be behind, someone will be ahead. So not good. Well, so that's why today Game of Life. Okay. So Game of Life. Let's get started. NumPy. NumPy is a Python library. Okay, let's get started with the Hello World. So world. Okay, here it is, Hello World. And this really working. My number is. Here you are. Okay. So I hope this makes sense. So the good thing about Python Notebook is that you can interactively program. So you write some parts of the programs, you press enter, and you see the immediate result. The approximately the same result you will be having in case you are using some modern how to say, interactive shells like PyCharm or VS Code or whatever. Uh, well, 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 well. Okay.
No, you can say that you can save everything you write.
What say again?
You can save everything you write. No.
Oh, you can save. Yeah. Sure. Okay. So let me do some more imports. So today is just a promotion. So this is for math calculations. This is for sort of big data. And there will be import matplotlib as plt. This is for nice. So, by the way, is it okay if I'm speaking in English? Because actually I can.
It's okay.
Okay, I can speak only English and Russian, and in Serbian I just know 2 songs because I sung. So I know Tamo Daleko and Hriste Bože. That's it that I know in Serbian. 2 songs and that's it. Okay, because we've seen it in our band. Okay.
Yeah, it's okay.
Oh, okay, great. So, if you are familiar with object-oriented programming, so we will be writing a class. So class in Pythons are exactly the same. So let's call it SSA, that is cellular automation. Okay, so this is the construction. I know that probably I am working with something np random rand 50 and I need the rule will be B3S23. So let me explain probably something. The game of life is a special is the dynamics of the cells. So let's first do it, and then you will understand from the code. So let me copy paste something from here. Okay, so this is just stupid copy paste. So this is the rule. The rule B is for birth and S is for survive. B is for birth and S is for survive.
I think it's a good idea to show a picture.
Yes,
about
exactly. So, I will definitely show a picture.
okay.
Yeah, I will do the iteration, so it's not some stupid code. So let me just do this class. So that is just for 1 iteration. Oh, it looks no bugs. Wow. That's fun. Yeah, and I also need some more libraries here. I need this. So because I will be doing everything in HTML. So, well, by the way, what I definitely what I'm kind of expecting is that you will, how to say,
Do this by themselves? What do you want to say?
Yeah. So just rewrite it like I don't know, kind of. Okay, LLCA, so it will be CA. Okay, let's call it LLCA, Linear Cellular Automata. Okay.
Natasza, dobro večer, da li se čujemo? Halo? super.
Everyone?
Yes, Natasha joined the meeting, so.
Okay. That's great. That's great. Okay, PLT subplots. Well, it's interesting. Model matplotlib doesn't have attribute subplots. So now you will see me struggling with the ChatGPT. So because I don't remember how to do it. Sometimes it's okay not to remember things, and okay, matplotlib, give me subplots example. Okay, so thank you so much. Here's a simple example where we create a figure with okay, go ahead. Oh yeah, I see. Yeah, this makes sense. So we need this. And now it may work.
Sorry.
Here.
You will explain later what you just did, right? I mean, everything. Like,
Yeah. I will definitely explain later. So what I am going to show now, I just want to show that kind of it is working. Guys, it is working. You can see, well, that is kind of life. Okay, let us do the let us do it's called different another how to say another way of living. It's called day and night. Come on. Oh yeah, here it is. Yeah, it works. Okay. Okay, now actually what we are doing, what is it? What is it
I'm also not
for?
sure that the guys know the rule of the this game. I think that you.
Oh, the rule is
Remind
custom,
the
and
rules.
I have just set the rule here. The rule may be any. It could
Yeah,
be
but
whatever.
this
Yeah. So
cells
let
that
me
die
probably.
and get born and everything.
Can you
Okay.
explain on a small example, very small
Of
example?
course I can. Yeah, sure. Let me so what we are doing here, we are doing the modeling of some very simple biological structure, the bacterial colony. So the how to say the life in 40 lines. Okay, how we can how we can do this kind of life. Uh, well. So I wonder how can I show it? Oh, okay. Let me show it in Google Sheets. Blank spreadsheet. Okay, so imagine a rectangular field, and each cell of this field could be either occupied and unoccupied. Does that make sense? For example, this cell is occupied and that cell is not occupied. Okay, for example, here are the 4 cells that are occupied. So for any given cell, for example, for cell days, and there is a life that happens in ticks. So time for this line is not a continuous time. It is t equals to 1, 2, 3, 4. It is discrete times. So we now kind of generations. Okay, 1, 2, 3, 4. And for any given cell,
Could you give me
there,
the access to
yeah,
this? Sorry, let's see. Could you
yeah,
give me
sure,
the
yeah,
access to
please.
this spreadsheet? I'll make some adjustments for convenience.
Of
Just share it
course.
with me.
Yeah, I can share it you here. So let me share with you here.
Not
So
quite
I
there
have,
yet.
yeah, so I have so many. Uh, I understand. I understand what you're talking about. Let me. So this is very. Here I can do
sorry, I
everything.
didn't think it would be so complicated.
No, it's okay. It's okay. It's okay.
Because
Just give me 1 second. Or if you can, you may share your screen. Is it works better?
No, I wanted to make some adjustments in the spreadsheet that you were using.
Okay. Let me do this, but give me 1 second because I can't give you access to NVIDIA. It's
Oh, I see. I see. You created it.
yeah, so it's okay. It's okay.
In
I
your
just do this
NVIDIA
on my
profile,
yeah, yeah. So
NVIDIA, and you can share. You cannot share it outside the organization, right?
I can, but actually I cannot. Well, even technically. So let me just create a Google Sheet under my personal account, and now I can share it with you. So game of life. Um, so what is your account?
It's charlotte.v.z.
Here,
Yeah,
this
this
one,
one.
right?
Yeah,
Okay.
thanks. Wonderful.
Okay, you're here.
Okay, yeah. Please continue.
Okay. So yeah. Imagine you have the following generation 4 times equals to 0 for any given cell. If you can figure out whether it will be a birth at the given cell. So if there are 3 neighbors, 1, 2, 3, there will be a birth. So here it will be a birth. Here it will also be a birth. You can see from here the original game of life. I believe it is birth B3s to 3. So these are rules of the life. So birth happens in case of there are three neighbors, and survival happens whether there are 2 or 3 neighbors. So and I believe that our picture, so we use all the so each cell has, so this is a cell and it has 9 neighbors. So it is north, northeast, east, southeast, south, southwest, west, and northwest. So there are 8 neighbors for any given cell. 8 neighbors. So instead of saying x minus 1, x plus 2, it's so complicated. So let us use it northwest, north, northeast, and so on. So for this cell, there will be also a birth. Why? Because on the directions of southwest, south, and southeast, there are 3 living neighbors. So there will be a birth on the next generation. And there are the only cells where there will be a birth. And for the current X, there will be survivals. So I don't know how to do this fancy coloring. Could you please do it well? Oh, no.
I can do the coloring. I'm just
Oh yeah. So
additional
okay.
color.
So there will
What
be
color would you like to be
survivals.
S? What color would you like S to be?
Well, okay, let it be green for survivals and let it be yellow for births. So for
Okay.
t equals to 0, we know that here will be the survivors and here there will be births. So on the generation 2, there will be 1, 2, 3, 4, 5, 6, 7. So the generation, there will be 7 living so t time at generation 7. Okay, very good. So now on the generation let me write it here, probably t equals to 0. And this is the situation. Let's draw t equals to 1. For t equals to 1, we have the situation where those guys are living. So let us figure it out. Where will be births on this? Oh, by the way, and we have rule B3 S23. It means that if there are 1, 2, 3, 4, 5, 6 neighbors, there it will be too crowded. So what does it mean? 3. It means that there are 3 living neighbors. And S to 3 means that 2 or 3. If there are 4 living neighbors, oh, it will be dead. Okay, so what will happen here? Here will be birth. Here will be birth. Here will be one more birth. Are there any more births? No, there will be only survives and dead. So this guy will be dead because of overcrowded. And these guys will survive because they have 2 or 3 people. So birth, survive, dead. So what will happen next? Next, we will have nobody here. And
you forgot to write number step. No,
yeah,
T.
of course. T is 2 here. Okay, so this is the generation for T is 2. Guys, please ask me questions. Or
It's
let us
do clear.
Yeah, clear. Okay, great. So let's follow up with a simple situation. Imagine you have something like this. What will happen here? So except the borders, they will be survived. They will be survivals. Those guys will be dead. And those guys will be birthed. So births are here. And births are here. So the next generation that is going to be on t equals to 1 will be this one. Does it make sense?
Yes.
Okay, so the original rule for the game of life that was invented, I believe, in 1970 or something like this, was B3 as to 3. But we can definitely set up any rule. And here it is, so it's so small, so I believe we can do it somehow. Okay, let's do a random initialization of the population. Okay, let me just set the rule, and I believe it should be working. So C equals to this. So LLCA, and let's do the rule of, for example, B2S2. Does it make sense?
Yeah.
So it means birth if only 2 neighbors and survive if only 2 neighbors. Okay, let's look at what has happened. Oh, nothing. Okay. 2, 3. Also,
You forgot C0.
C0 is the random initialization. Oh, interesting. Let's stop it. Anderson. Okay. C0. Okay, here it is working. let me include, for example, to the survival rule, survival 234. What does it mean? It means, oh, by the way, from here you can see that the
Is it my internet or his?
His.
I see. NVIDIA has a very unstable Wi-Fi.
The Silicon Valley is a place with bad Wi-Fi.
Yeah, sure, that's the case.
will be dead. So the next generation will be XXX. So
Wait, I was just going to say that we've lost him at some moment, but we've lost him again. Guys, but while we're waiting, you know this game, right? I mean,
Yeah,
yeah.
we know.
Dream, maybe we should turn off our cameras. Maybe it's too much data for the channel.
Okay, you can just turn off.
Well, I wonder if it's
Alexei. Proc. Okay, Alexei was telling how to proc this game on Python. So we have several labs in Python which can use us for created. So I think it was rather interesting, and of course I told that we can save the whole code and then we can share this code and everyone can use and play with this code to understand how to use this game and how we can do everything in it. Okay, but something goes wrong. So, well, first of all, we should understand that we can change rules as good as we want. So we can change everything and we can see how this game is working. I don't know exactly what Alexei wanted to show, but as you could see, it was rather interesting. Okay.
I tried to call him, but I couldn't get in touch with him. So let me ask a question. Okay, so we see that like a computer can make some not predictions, but just calculate the condition of this game. Is there any way to like model it and approximately calculate what will happen in, I don't know, 1,000 steps? Or the only thing we can do is to make all these steps and then see the result.
We can do everything we want. So if we want, we can use 100 or 1,000 steps. It's not a problem. It's not a problem for a modern computer to.
Yeah, but okay. And what about 1 billion of steps? A billion of billions of steps.
No, I think this things Alexei wanted to tell us. So he has a very big experience in this game.
So he has some secret
Yes,
he
of
wanted
course.
to reveal.
A lot of secrets and a lot of life hacks about this game. So it's his theme.
It's a pity we lost him. Yeah, I'll try to reach him once again.
No, as I know, he works with this game at least, I think, 15, maybe 12 years. So he had his own course about it in Moscow. So he's the best one who can tell us about this game. No, one of the best ones who knows everything about this game. Okay, maybe it's a good idea to create something in. Maybe I ask Alexei to write something for everyone and to play with this game. And I think we can continue in the next lesson. No, for example, I can ask Alexei to write several questions for everyone, and I ask him to share this code, which I thought it's Alexei. Okay, I ask Alexei to share this code and to create several questions and several sentences how to use this code. I think it's a good idea. Am I right?
Do maybe have some? Yeah, I think yes. I think we should do this. And send. Stefan, do I have your email or any kind of contact with you?
Just my name at mysurname.com if you're looking for mail. It's not school mail. Stefan at dingarts.com.
Okay. I think I can memorize that. What was I going to say? Yeah, it would be nice if you could fill in the form on the website. Would be
Yeah.
convenient for me.
I
No,
didn't
it's
see the
not.
form.
It's not urgent. I mean, it's not urgent, but just in case.
Yeah, on which website? Just I didn't see the form.
It should have been in the message from the school. It's right now. Andrei, maybe you have some interest in some short interesting problem that you can show us right now since we're here. If not, we can.
To
You
say
can
the
finish
truth,
more, but maybe some. You always have we always have plenty of interesting things.
okay, I can show some maybe popular videos about this game. Wait a minute.
Hello everyone. Yeah,
Oh, you're back.
realized that I'm talking and talking and talking and nobody's here.
I tried to call you. I mean, I called you. You didn't answer. I called you
Yeah.
twice, and I even wrote you. I asked if you were alive,
Yeah.
And you didn't answer. What happened? Is it
I
Wi-Fi?
have no idea what happens. Oh, probably this is Wi-Fi, probably anything. But I found out that I'm talking and explaining and discussing and nobody's here now. So let me do share my screen one more time. And please let me know on what place I was disappeared. So I was trying to explain how it works for different generations and rules. Did
No,
you
no, no,
see
no.
this?
It's too far, too far.
Okay, too
You
far.
stopped at when you pick on picture. Come back to
Picture.
Excel table,
Here.
and you stopped at the picture at the left.
This picture.
Yes.
Wow. We missed some time. Okay, okay, great. So the next thing I was just talking about, if you have the generation that looks like this, it will be flipping forever to this and so on. And this is the proof of this fact. So there will be 2 births here and 2 dead guys here. So if you have this generation, it will be flipping into this, then to this, and so on. Okay. Let me get back to the picture. Okay. So NP random rand 50 to 50. NP random rand more than 0.1. Okay, yeah, nice. So actually I was talking about this difficult stuff. Did you hear it or no?
No.
Okay, so let me explain. For any given cell in the matrix, imagine that you have this matrix of living cells. So 0 means that the cell is dead, and 1 means that the cell is alive. I'm calculating the number of neighbors. For example, for this cell, the number of neighbors will be 0. And for that cell, the number of neighbors will be 3, because we have 1 neighbor to the south, 1 neighbor to the southeast, and 1 neighbor to the west. Here it is, 3. For this neighbor, the number of neighbors will be 5. And I made a mistake here. Yeah, does make sense. So for any cell, I create another matrix, and each cell in the matrix tells me how many neighbors are there for any given cell. For example, for this cell, it is the number of cells will be this. So this situation is exactly as for the Minesweeper, where this number 111 tells you the number of bombed neighbors. If you saw this picture, so actually this picture is exactly the matrix of neighbors. Okay, and based on the matrix of neighbors, we can calculate whether this cell be occupied in the future, or well, it will be survived, or it will be dead next time. For this rule, B2 as to 3, this will be this case. For if we do the more strict rule, birth in case of 3 neighbors and survive in case of also 3 neighbors. Oh, it means that if the neighbors is different, it is 2, 4, and so on, that there will be a dead cell, 0 cell. So what is it? Well, this is Python, and Python working with matrices. So n is oh, let me do probably some more stuff. Just to oh, interesting. Okay. Here you can see what is x. I want x to be some random numbers from 0 to 1, and 10 to 10 is the shape. So I can do it 2 to 2. So here are 4 random numbers. Or I can make this random numbers as a vector. Does it make sense? So here I turn the shape. The shape could be also 3-dimensional, then it would be a tensor. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And we are working on planes, so there are 4 cells. And here I'm setting the following rule. I want them to be greater than 0. Okay, so this is x. And for example, y is x greater than 0.8. Now let me print x. And let me print y. You see, false, 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 true. Why it is true? Because this this value in this matrix is greater than 0.8. Does it make sense?
Yes.
Okay, good. So actually, this is how to work with matrices. Or if I say that it is less than 0.5, here you are. Or it is greater than 0.1, there will be almost everyone will be true except one, that is this guy. So this is actually this is a variable that tends to be a matrix. Okay. Now let me turn it to integer numbers. Okay, so y he doesn't know it. Okay, probably this he knows. Okay, here is y. And here is x. Yeah. Okay, so this is for the initialization of the original population. So here it will be approximately 1/2 of them will be occupied, or in this case it will be okay. 0.3 is the probability. Okay. Here you are. Okay. So the day and night rule is so this is day and night. This is fractal growing. Yeah, here it is. Oh, it will not survive. Yeah. So these are only 2 that are survivable. Okay, let's give some more energy to this. Okay. Oh, you see. A little bit better. It also dies, but not as fast. Okay, so actually today's topic is just to show you some parts of the mathematical modeling. Let's do a different, let's do some, how to say, not only gaming. Look, actually this update fig, yeah, update fig gives us it just iterates for the generation, but lets us create a graph. For example, how many living cells are there for any given iteration. Does that make sense?
Yeah.
Okay. Living count Okay, yeah, we need first of all to calculate the number of living cells. That is just sum of S. So living count append. I don't remember whether it works with this Python. I believe so. Or why sum? Wow. Interesting. Oh, just 5. Okay. Dot sum. So living count append C sum. Okay. And here, let's look at it. Oh, it doesn't work. Oh, it tells me something bad. Name C is not defined. Of course, it's not defined because it is GC. Okay, it doesn't work. Print GC sum. Oh, here you are. Okay, so this number is decreasing. It is really decreasing. Okay, living. Let's call it L count. Good. Here you are. So we have the graph of living cells. Now, this is for only 50 generations. Now let's create. Why? Okay. Here you are. Let's make it beautiful. So we have this rule. Sounds better. Am I here? Does anyone hear me and see me?
Yeah.
Or
Yes,
I am
it's
alone
okay.
again?
No,
Okay.
that's
Good. Why label count of living cells? Oh, Now it looks much better. You can see it, right? Okay, let's prolong the generation up to, I don't know, 500. It will take a while.
While it's calculating, what are we trying to do? Are we trying to make like a simple model for this
Yes.
game and predict the
Yeah,
number of
exactly.
living cells
We are
so that we don't need
trying.
to run through all the iterations? We're losing you again. Am I right, guys? Are we losing him, or
Yeah,
am I
we are
getting lost?
losing him.
Yeah.
I have write him about it, and he couldn't get the message. I think Alexei has problems with internet now.
Just when it started to get interesting.
And
Just recorded the finish of.
okay. Okay, one more time. I think we ask Alexei to share us the code, to write us several sentences about this code, and to write us several questions about this code to try it. And our main our main problem is to repeat everything Alexei did today on his screen. Just to repeat. And the next time we see a lot of different, very interesting examples.
Yes, okay. I think that Alexei is still trying to get through. I don't think that we should wait anymore. Thank you guys for coming. I'm sorry for this technical inconveniences that we experienced. I'm quite surprised because we had several quite long conversations with Alexei over the previous several weeks, and nothing nothing like happened even once. So I hope. Oh, we can see now, but we can hear you. No sound. No sound. No sound.
Okay, now I see. Okay, can you
I was just saying that yes, that we, I was just saying that we had several conversations and nothing like this ever happened. And I was just going to finish our meeting. However, if you want to add something, please do so.
I just wanted to add the only thing. So let me share this Jupyter notebook to you. So you may share it to everyone. So you can just run exactly this code.
I think it's a good idea to write several sentences about this code. How to, for example, how to create pictures, which we saw, and and we wanted to ask you to write several questions for us about these systems, and something might be interesting.
Okay. So yeah, sorry for the connection. So today it was not so good, but I hope how to say, the pictures were nice and they were color. Well.
Okay, thank you,
what
everyone. Hopefully, see you all next time. And
yeah, next time there will be better connection. Definitely, I will find the better Wi-Fi here.
Okay, thank you.
Are you in office of NVIDIA?
Yes, I'm in the office of NVIDIA. I'm here. Yeah. And this is okay. So you can see that this is a day. So now it is 11 a.m. So it's sunny day, warm morning.
Another boring warm day in California. Yeah.
Yeah, kind of. Yeah. True. Busy day.
Okay, this was our 0th meeting, which means that it wasn't supposed to be too serious. It turned out to be to be with some technical difficulties. However, I hope that the next time we'll have some more people, because as I already said, we did this announcement quite late. It's my fault because I was making the website too long. So in a week, we'll begin with the serious part of the program, and we'll start probably from monkeys, right?
Yes. Well, actually, monkeys is
and
a serious
bananas.
problem, and we probably need something. How to say to get connected, because I
Some
believe
introduction
that
to monkeys, right? So
introduction to monkeys. Yeah.
okay, so
Maybe maybe it's a good idea to finish about live games, because we just started and we saw only the system which were dying. And I think it's a good idea to show children a system which can rise, and the system which can be stable, or something like stable.
Well, classical game of life is kind of stable. Well,
No, some interesting pictures. I think it's a good idea just to show.
Yeah.
It's very interesting, and everyone can do it. So I think it's a good idea to show it before monkey. No, just to create something
okay,
very
guys, I think we'll
beautiful.
discuss this. Yeah, thanks. Okay, so that's it. Thank you, everyone, and see you next week.
thank you.
Bye bye.
Thank you. Bye. See ya.
See you. Bye.
Bye.
Bye.